Okay guys, this is the paper 1 revision video for chemistry. We're going to be going through a few different practice questions. Some are exam questions, some are based on exam questions with slightly tweaked numbers. Some are just questions that you could get on an exam but haven't not directly from an exam paper. Okay, but it should be a really good mix of questions. We're going to be going through a few different paper 1 topics. So have a go, follow along in the video, have a go at all the questions and see if you are ready for your exam. Okay, let's get into it. So the first question in our paper 1 revision is all about mixtures and separating mixtures and separating things which are chemically bonded and identifying which one's which and how to separate them. So on the right hand side we've got a few different methods of separation. On the left hand side we've got the substance and the mixture, and we're going to try and match each one to the way you'd separate it. So for the first substance we got here is a teaspoon of salt dissolved in water. So you might be able to know the answer straight away, but I'll go through each one just in case. Now, salt dissolved in water, would you use chromatography for that? No, generally chromatography you're going to be used to separate kind of different colors. That's kind of the clue is in there. And the idea is that when you have maybe ink or something like that, you can spread it out into the different colors of ink. So not suitable for a teaspoon of salt dissolved in water. The next one then, crystallization. So crystallization looks like a good candidate. So hopefully you guys are all familiar with crystallization, where essentially you evaporate off the water and you're left with the crystals of the salt. Okay, so this looks like a good candidate, but we'll check the other ones. Then we got electrolysis. Now electrolysis, basically, if you guys don't know, you have a molten compound in there and you separate out the ions. In this case, you wouldn't use it because essentially the water and the salt themselves is not an ionic compound. Okay, this we just mentioned. Then you have filtration. So filtration, generally if you have solids mixed with liquids, you can use filtration because the filter paper will let through the liquid and will block out the solid. Unfortunately, it won't work in this case because the salt is dissolved in the water, so it's now no longer a solid, it's actually aqueous. That's what the state would be. And the last one there is fractional distillation. So fractional distillation is used when you have different boiling points, a mixture with lots of different boiling points, and then you can basically boil it. As you go up your fractionating column, the temperature changes and it condenses at different stages. Now again, a teaspoon of salt dissolved in water wouldn't quite work because essentially the salt and the water, you could boil off the water, but essentially you're not going to be able to boil off the salt, so that wouldn't work. Okay, so it seems like the candidate then is crystallization, and that's the one we'll put. So you could have got the answer straight away, but I just thought we'd go through all of the different possibilities. Then we've got fractions of crude oil. So again, let's do the same. Chromatography, no, for the reason we explained before. Electrolysis, also no, again it's not an ionic compound. Filtration, again wouldn't work, you don't have solids in there. And the last one, fractional distillation, and that would work because essentially in crude oil you have lots of different mixtures of oil all mixed in together, and they have different boiling points depending on their chain, the length of their carbon chain, and therefore if you use a fractionated column they will condense at different stages. Okay, and the last one there, rocks mixed with water. So you should identify here you've got a solid mixed with a liquid. That is just going to be simple filtration. Okay, so this is just a simple mixture, you can separate it with filtration. So that is the first question. Let's move on to another practice one. Hopefully you guys got that one correct. So here we have an acid-base question, acid-alkali question. So here, which ion do all alkali produce in aqueous solution? Whenever you have a base that is dissolvable in water, i.e. makes an aqueous solution, that's essentially what we call an alkali. So in this case then, what ions are produced when you have an alkali? So an alkali, I'll give you guys an example, is NaOH. Lots of different examples. You could have CaOH. So these would all be examples of bases, and if they were soluble in water, which some of them are, they would be alkali. Okay, so in this case you can see what they have in common is this hydroxide ion, and you should know it makes this OH minus ion. Okay, so it's the opposite of an acid which makes a positive ion. It actually makes this H plus ion. So if the question was about an acid, that's what you put. The H minus and the O2 minus are not so relevant here, but hopefully you guys can see then how that works in terms of how an alkali dissociates. So if you take this sodium hydroxide, you would produce Na plus and OH minus, but the key part of the alkali is always going to be the OH minus. This is what makes it basic or alkaline. Okay, that's what increases the pH. Okay, so now moving on to a mathematical question. So maths questions and quantitative chemistry is a very popular topic in the exams, and you need to be well prepared for all manner of quantitative chemistry questions. So this is a nice practice one to test how you are on that topic. So we've got an equation for a reaction here. You basically got silver nitrate reacting with sodium iodide, and it forms silver iodide with sodium nitrate. And the question we're asked is to calculate the atom economy for the production of silver iodide in this reaction. So the key thing here is, what do we actually want? We want this silver iodide. Okay, now that's the first question you should ask yourself when you have atom economy questions, all right? So now that we know that we want silver iodide from our reaction, it should be fairly simple then to work out the atom economy. So what we're going to do is we're going to work out the total molecular mass. So if you were to work out the total MR, molecular mass is going to be 170 from the silver nitrate plus the 150, and that's from the sodium iodide. Okay, so that's what you start with and that's what you're going to end with. Okay, so you remember the total molecular mass should stay the same on either side. So we get 320 here for the total. Now to work out the atom economy then, that's going to be the total, but we need to work out how much of our product we actually produced. So for the product MR, we should be able to, that's actually given to us straight away as 235, okay? So we can put that in there. And so now it's just a simple case of then knowing what to do with these two numbers. So you want to work it out as a percentage, so we do 235. That's how much we actually wanted, over the total, which was 320. So 235 of our atomic mass or molecular mass went into our actual desired product. 320 was a total. So the total atom economy, if we essentially times that by 100%, we should get an answer of 73.4375 and so on percent. Okay. And the key thing here in the question, we want to know how to round it. Well, it actually tells us round to 3 significant figures, and so we should hopefully be able to round this, and you should get a total answer of 73.4%. Okay, so that's 3 significant figures. Okay, so that is a good example of a quantitative chemistry question. Hopefully you guys got that one right. And yeah, it's a more simpler one, atom economy. As long as you know the formula, you should be able to deal with it. Okay, a reaction question. And this time we're asked to draw a dot and cross diagram to show what happens when atoms of sodium and oxygen react to produce sodium oxide. Okay, so it's a dot and cross diagram, but the first thing we need to actually identify is what type of reaction is this, because depending on the type of reaction, we'll know what kind of compound or what kind of compound will be formed. So in this case, actually, we have atoms of sodium, which is a metal, reacting with atoms of oxygen, and this is a non-metal. So when you have a non-metal and a metal reacting together, what kind of compound do you get? You do actually get a ionic compound, okay? And actually you do get it in this form as well. So sodium is in group 1, so you should know what happens when group 1 elements react with oxygen. You're going to have 2 sodium atoms for every 1 oxygen atom, okay? So that's basically what we're going to see here. In fact, it would look something like this, okay? Na2O. And in order to balance it, essentially you could put a 2 over here to start off with. That gives you the 2 sodiums that you need, and then you need 2 oxygens over here, so you probably put a 2 over here, and then you probably then change this to a 4. Okay, and then everything is balanced like that. If you wanted to balance it, we're not asked to balance it, we're just asked to draw the dot and cross diagram. And so for our ionic compounds, when you draw the dot or cross diagram, essentially what's going to happen is the electrons are going to be transferred from one to the other. Okay, so let's start off then with drawing the sodium. So we'll draw the sodium just how it would look like at the beginning. And remember, we're going to have 2. So if we just take this on its own, ignore this 2 for now. We don't need to worry about that. The compound itself, the formula is Na2O. That means we have 2 sodium atoms for every 1 oxygen atom, okay? That is what forms our compound. So in our compound, that's the formula we're going to be looking at. So we need to draw 2 sodium atoms and 1 oxygen atom, okay? And in fact, they're not going to be atoms, they're going to be ions because they're going to be losing electrons. But let's start off then drawing our first sodium ion. So first we'll just start off with drawing the atom. And so for an atom of sodium, you're going to draw the first shell over here, and then the second shell. And you look at the periodic table for this, and so according to the periodic table, you should know because sodium is in group 1 and it's in period 3, it's going to have 3 shells and 1 outer shell electron. So that's what it's going to look like. Now this would be a sodium atom, but we know it's a sodium ion, and we know that ions of sodium, because they're in group 1, they form 1 minus ions. Okay, that's the easiest way to do it. Just look what group it's in. You can tell it's going to form 1 minus ions. So we'll instead make this into an ion. It will lose the outer shell electron, and it will look like this. So you have a negative sodium ion here, okay? 1 minus sodium ion. Now we know we're going to have 2 of these, so essentially we can actually just grab this and copy and paste it. So now that is looking pretty good. So we can take this and put these next to each other, just like that. Okay, so we got a sodium ion, and I'm going to leave some space in the middle because essentially we need to think about what's actually going to happen physically, right? So because these two both have a negative charge on them, they're both negative ions that have been formed, they would normally repel each other. So the only thing that's keeping this as a compound and keeping this together is an attractive charge. And where does that come from? Well, then we need to look at our oxygen atom, or actually our oxygen ion, because remember it's an ionic compound. So what kind of ion will oxygen form? Well, oxygen it could form different types of ions, but in this compound we can see if we're going to have a minus sodium ion here and a minus sodium ion here, the overall charge of the compound needs to be neutral, needs to be 0. That means we need a 2+ charge from the oxygen, so the oxygen ion is going to be formed with a 2+ charge. So let's start off then with drawing our oxygen atom. So again, we can draw oxygen in the middle, and we'll just draw the atom for now. And so again, you can do it by looking at how many electrons are in the atom, which will be the same as the proton number. Okay, so we draw our oxygen just like this, and it's going to have 6 outer shell electrons. It's in group 6. Now we need to decide what do we actually do, what kind of ions are formed. Well, the oxygen essentially is going to be a 2- ion. A 2- ion, and in fact over here we need to make a correction because we put these as minuses, but they should be actually positive, because if you think about it, they lost an electron, they lost a negative charge, so they should be positive. So correction there. So then if we come back here, that kind of tells you what to do here. Actually, you're going to gain an ion. Okay, you're going to gain an electron to form a negative ion. Okay, so when you gain that negative charge, you form a negative ion. And I'm actually going to go here and just change the these crosses to dots, because it is a dot cross diagram, and that's the only way we can differentiate where the electrons are coming from. Okay, let's add the dots on here. So it's got 2 inner shell, and then 1, 2, 3, 4, 5, 6. And the idea is then it gains 2 electrons, okay, because it forms a 2- ion. So 1 electron there, 1 electron there, and these are crosses to show that the electrons came from the sodium ions. Okay, so then this forms, because it's got 2 extra electrons that's been added on, it forms a 2- ion. Okay, so that would be how you draw your dots and cross diagram for an ionic compound. You guys should all be familiar with that. Okay, moving on to a little bit of redox. So hopefully you guys have revised this. So what is oxidized and reduced in the below reaction? So we've got zinc and copper sulfate reacting to form zinc sulfate and copper. So the first thing you should be able to notice straight away is this is a displacement reaction. Okay, and so essentially what has happened is the copper in the copper sulfate has been displaced by the zinc. The zinc has then formed the zinc sulfate instead, and the copper has been left free on its own. Okay, so that's useful to know. And the first stage then into understanding whether what's being reduced, what's being oxidized here, is to draw out the ionic equation. And so we can actually see what's happening. We have zinc, start off with zinc and copper 2+ ions. And we're only interested in the zinc and the copper when we come to our ionic equation, because our sulfate stays the same. So our zinc initially is just an atom. It's not an ion, because it's not chemically bonded or anything. It hasn't formed an ionic compound or anything. The copper sulfate, on the other hand, the copper has formed an ionic compound with the sulfate to form copper sulfate, and SO4 or sulfate is a 2- ion. Okay, so you should know that this is a 2- ion, very common, it comes up a lot. And so whatever is bonded with is going to be 2+. And you should also know copper is going to form 2+ ions generally. Then on this side of the equation, on the right hand side, we now have zinc sulfate. So the zinc, now for the same reason that copper was 2+, now zinc is going to be 2+, because it has to balance out the sulfate. And copper now essentially has just formed copper atoms with no charge. Okay, so you might be able to do it from here, but we're also going to go ahead and draw out the half equations as well. And essentially you can see what's happened. Zinc, the atom, has gone to the zinc 2+ ion, And so we need to say, how did that actually happen? Well, essentially, if it's formed a 2+ ion over here, then remember the charge on this side was 0, so the charge on this side has to be 0, and therefore to balance this out, you need to have 2 electrons over here. Okay, so the zinc has released 2 electrons to form this 2+ ion. You can do the same thing for the copper. So they started off with copper 2+ when it was in the ion, and then you formed copper over this side. And so to balance it out, we need to essentially have 2 electrons on the left hand side. So let's actually make some space for that. But essentially here the copper has gained 2 electrons, the 2+ ion gained 2 electrons to form neutral copper. Okay, so hopefully that's pretty easy to follow. And then therefore we can use the fact that we know what oxidation and reduction is according to our acronym OILRIG. And so oxidation is loss, reduction is gain, and we're talking about electrons here. So because zinc essentially lost electrons, remember it started off as this neutral and it ended up positive, so it ended up losing electrons. Therefore the zinc is the thing that's been oxidized. So we can write that over here, zinc equals oxidized. And then the other thing was the copper, and so obviously if the zinc has been oxidized, so that means the copper has been reduced. But let's take a look at it. The copper, it gained 2 electrons, so reduction is gain. So because it's gained 2 electrons, we can therefore say the copper has been reduced. Okay, so that is a redox reaction there taken from the start to the finish to see exactly how that's worked. And one more quantitative chemistry question for you guys here. Iron chloride is produced by heating iron in chlorine gas. The equation for the reaction is given over here. We've got 2Fe plus 3Cl2 goes to 2FeCl3. Okay, calculate the volume of chlorine needed to react with 14 grams of iron. And we should calculate the number of moles of iron used, the number of moles of chlorine that react with 14 grams of iron, and the volume of chlorine needed. So this question is worth slightly less marks because they've actually given us the steps on how to do it. So as long as we follow those steps, they've laid it out for us, we should be able to get the final answer. So let's go ahead and try to follow those steps then. First thing we want to do is we'll calculate the number of moles of iron used. So we should know the formula. The mass is going to be equal to the MR multiplied by the number of moles. And therefore, if we rearrange this for the number of moles, we should get is equal to the mass divided by the MR. Okay, nice and simple. That's the first step is given to us. So let's go ahead and do it. So the mass in the question is given as 14 grams. So let's take this 14 grams over here, and grams is the correct unit, so we don't need to change it. So 14 grams divided by the MR, and so the MR of iron is also given to us as 56. So we can just plug in 56 over here. Remember, we're just working out the number of moles of iron that we used, and that is just the Fe over here. So the MR, the number of moles first of all is going to be 0.25 moles. Okay. Now we want to work out the number of moles of Cl2, and so remember the ratio of Cl2 to Fe, if we actually get rid of that, we can see basically for every 2 Fe's or every 2 ions, we have 3 Cl2s. So essentially if we have 0.25 moles of iron, that means we do 0.25 multiplied by 3/2 to get how many moles of chlorine we get. Okay, so remember that's the second step that they've given us here. So the number of moles of chlorine is going to be 0.375. Now a common mistake people will do is they'll take into account this number at the beginning over here, and you might multiply the MR by 2 or something like that. That's not correct, because remember this is just this would just give you the ratio, the molar ratio. Okay, so when you work out the number of moles of iron, that's when you use these numbers to work out how many moles of everything else you'd have. Okay, so it already tells us we've got 14 grams of iron, so we just use that with the MR of iron to work out how many moles, and then we can use the numbers at the front to work out the ratio. Okay, so that's exactly what we did here. We did 0.25, essentially we divided by 2 times by 3 to get the number of moles of chlorine, and we get 0.375 for the number of moles of chlorine. Okay, let's actually label that here so we know what we're talking about. Okay, perfect. So then let's look at the third step that's given us. Now we can use that to find the volume of chlorine needed. And quite helpfully it told us that 1 mole of gas is 24 dm cubed. And the reason why that's useful is you should know that Cl2 is gas, and it actually tells you at the beginning over here as well that the iron is reacted with chlorine gas. So if 1 mole of gas is 24 dm cubed, and we want to find the total volume. So we know how many moles of chlorine we've got. We've got 0.375. So we take that and we multiply that by how much volume 1 mole would be. So multiply by the number over here, which is 24 dm cubed. This multiplied by 24, you get the total volume, which is going to be 9.0 decimeters cubed, because you have to use the same unit over here. Okay, so hopefully that all makes sense, and your final answer should be 9.0. Okay, and the reason why we put a 0.0 over here, because we need to look at the significant figures given to us in the question. And so if we look at all the numbers over here, we've got 14 grams, that's 2 significant figures. We've got 14 grams again, we've got 56, which is 2 significant figures. We've got 24 over here, which is also 2 significant figures. So the least number of significant figures given to us in the question is 2. Therefore, our answer should also be given to 2 significant figures. Okay, so we'll leave it there for today's video. Let me know if this kind of video was useful to you guys, and we'll look at making some more if so.